So Thursday, you said it was a 2 sample. Is it means or proportions? Proportions, and then we do a test or an interval. Interval. So today, we're going to switch and do it with a test instead. So we're still going to deal with proportions today. We're still dealing with 2 sample, and we're just moving from interval to test. So there shouldn't be a whole lot that changes about it. I do want to print out. Two, 4, 6, 8, 10. So with the one from Thursday, there's one part that I said I'm going to do a little bit funny, and I didn't want to explain it in the notes. I'd rather wait and explain it when people are here. Was when we checked for normal. So we checked for normal, and we're dealing with proportions. In general, we have to do what process? Like we're checking what times what? N times P, N times 1 minus P. But now we have 2 N's, which means we have 2 P's or P hats or P naught in some form, which means really we have 4 different things that we have to account for there. So we have 2 different samples and a success and failure for each sample. So the way I choose to do this to make it a lot less wordy and just as descriptive is to basically make a box, which is a 2-way table, and make one side of it my different populations, and then one side of it my success and failure. So I am not going to go right then. I'm losing my mind today. Oh, okay. Yeah, that is not a 4-step process at all. Sorry. So, okay. No, all that. So the one we did on, let's just look at our homework one. Now does everybody have 4 steps? No. That's good, both of you. So the one we did for homework, what were our 2 different populations? I can't remember which one was. Is this one that was long and wordy? Yeah. Okay, then let's do the example problem instead. The example problem, my populations were male and female, and then what were our success and failures? Okay, that's supported. Okay, so I would end up doing something like there were at least 10, and then so the part that was with both male and female was that they were what, residents of that town? Residents of what? Did it give you a name or just said this city? There are at least 10 residents of a particular city that were that. Was it men and women or male and female? And then the did not was intend to vote for Obama, right? Is that right? Mm-hmm. In 2000. Okay. So instead of writing out a giant sentence or sentences, I think it's easier to do a chart like this to where I have population 1, population 2, success, failure, and check marks. And I think it ends up being easier to do it that way and less space and less wording. Same point, just as detailed. So that's the one thing that I chose not to do on Thursday when no one was there. But I'm going to start writing that part that way. So let's start with our generic 4-step. So this is a 2-sample. This is our title. The interval for difference in proportions. And this is chapter 10. And this one is number 7, right? So Thursday was number 6. Or do I have that? Am I off by one? This is number 8. Does that sound right? I think this is number 8. I didn't have this sheet in front of me on Thursday, so y'all didn't write one down. So the one from Thursday was number 7. The one for today is number 8. Oh, so then I wrote interval. We've already done interval. I think I, along with half of the class missing today, still on the mentality of we not having school today. Okay, so when I do this one, if I am doing a test, just a general test, like so if you have your other 4-step process sheets with you and you have one that's a test for proportions, how do we start these problems? Well, if it's a test, what do I know I have to have in state? What? What else? What else? Yes, population parameter, what else? And your hypotheses. So what can I do between population and parameter where I only do one and it does the other one within it? If I define my population, does that define my parameter within there? No, but if I define my parameter, does it define my population within there? Because proportion. So and I don't remember how detailed I got about writing this on Thursday because I don't have this sheet in front of me. Proportion of population. Again, write it however you've been writing it. Stay consistent with the way you have been choosing to write it. And I might write population 1 here. So define P1, so what's the next thing I define? That have P2, and like I said, when I write generic, I write it as P1 and P2, but I don't actually use 1 and 2 very much with my subscripts. And so I write population 1 and population 2 the way I'm choosing to write it out, but I don't write success any different because it's still defining success the same way, just up from a different group. So I've got that accounts for both my population and my parameter, populations and my parameters. So then you said the other part that always goes with state is what? The hypotheses. So H sub 0, I would have defined, or I would choose, so when I said we subtract the 2, right? And I got to define that in the way that I chose my wording. Did everybody understand that I could have chosen either direction? So I could do P2 minus P1 or P1 minus P2. The same thing works here. So I'm just writing it as P1 minus P2, but that doesn't mean it has to be that direction. I'm writing this in my other color, but I'm writing it as 0. Technically, that can be a number other than 0. But as far as this class, we don't deal with that much. I might want to check to make sure that one of them is at least 20% higher than the other one, in which case I'll put 0.2 there. But most of the time we deal with seeing if they're the same or if they're different. I can't remember if I talked about this in the video or not, and don't write it on your paper. P1 minus P2 equaling 0 is the same thing as saying P1 what? Equals P2. So you will see other like problems or documents and stuff that has it written like that. That's technically saying the same thing. So then my alternative, whatever direction I chose here, I need to choose that same one here. So I got to, this is where I chose to define my direction. And then again, still I get to choose less than, greater than, not equal to. And whatever number was there is going to be the same number, even though technically most of the time we use 0. So my null hypothesis is that my two different proportions what? Are, think about the way I wrote it right here, they're the same. So our null hypothesis, our assumption is that they're the same. And then what's the other thing that usually goes with state? And again, I don't care what you choose to write there, but again, which one do we use if one is not given? So just like I said before, the brunt of the work in these, in all of chapter 10, is going to be in plan, just because you're going to have to check your conditions for both samples. First part of plan is always what? So we're at the point where, even though I haven't done this one yet, you should be able to tell me what the method is. It's going to start with what? So it is a 2 sample. I have a decision here technically. Technically, my decision is always if it's what or what. Z or T, but we're dealing with proportions, so it is Z. My next decision is whether it's interval or test, and so this time we're doing test. And then the end is for proportions for means, and this one is for difference of proportions. There's a fifth one. So the question was writing difference in proportions not implied with the 2 sample, and I understand what you're saying. The fifth, like we cover 5 things during this chapter, and the fifth one is actually we start out with 2 sample, but we do it as a 1 sample. And like I'll explain it when we get there, but that's kind of, yes, it seems very repetitive at this point, but that's the only reason we do that. All right. First condition is what? Random. I don't care if you write check conditions or not, but if you've been doing it, you might want to. I don't remember how I wrote this on Thursday. Did I write population 1, population 2 split? Okay. And then something about, or check both of them. Random selection versus assignment. And so you might not write it as a checklist with like them separate like that, but because people tend to forget it when they're first starting these, I wanted to write them separate to be explicit that you're writing it for both. Usually it's going to be like one sentence that says like both males and females were randomly selected from residents of the city. All right, so my next condition is what? Still having people with this issue here, which is reasonable. I'm doing some form of n times p and n times 1 minus p. I have two different n's, so I know I'm going to have to do it once for, I'm going to have to do n times p, n times 1 minus p with n1. I'm going to have to do the same thing with n2. So the issue becomes in making sure that you write your notation for the p correctly. This is a test. We did before intervals. So if I have an interval, or if I'm doing an interval, do I know my p naught? What am I estimating in an interval? The population proportion, or the parameter, right? So I only know the what? In terms of p's, what do I always know when I go in an interval? I only know p hat, so we have to use p hat for intervals. If I'm doing a test, do I have something better to use than p hat? So go back to one sample. We had to do this when it was an interval. But when we did a test, we did n times what? So we're using this version now. Oh, wait. Okay, so where would that have come from? Let me go back to this. Where would that have come from? Okay, does our hypothesis look like that? So I don't have a number that parameter that we're trying to estimate is. So do I actually have something better than p hat for this? No. So we have to use p hat 1 and p hat 2. So you're always given a hat, the p hat. So you always can use that, and you ask yourself, do I have something better? If I do, I use it. If not, then I have to use p hat. So here I don't have anything better. When I actually have a problem and everything written out, that would make more sense. Yeah. Okay, you're asking the right question, and the answer to your question is yes, but we wouldn't have to do a test. That would just be finding the minimum sample size. But you're asking the right thing, yes. Each of these are greater than or equal to 10. Like I said, sometimes I just shorthand it and write that all of them are greater than or equal to 10. I still want you to write out in context. But this is where I would do the box of there are at least 10. So you might choose to write it as there are at least 10 something. And then do this so that you remember population 1, population 2, success, failure. And then we always end with, so there might be more wording down here, but it depends on the problem. And then so we can use an approximation. So what's left? Independent, which is 10% condition. And I have to do it for both. So I don't care how you choose to write it. I don't remember how I wrote it last time. In capital N1 is greater than or equal to 10 in little 1, or little lowercase n1. And capital N2 is greater than or equal to 10 times lowercase n2. And write out in context of there are at least But this is kind of weird because you're going to have at least number of this population and number of this population. So I might write it as it's not necessarily the way you're going to write it, but just so that you have it enough to where you understand what it is I'm talking about. All right, so plan is the majority of our time spent. I do. What are some variables that the problem's going to give us? What kind of P's did we say we're going to get? Hats or not? How many of them are we going to have? We're going to have P hat 1, we're going to have P hat 2. What else are we going to have for 1 and 2? And sometimes I change the order there. Sometimes I'll write P hat 1 next to N1 and then P hat 2 next to N2. That's up to you. Now, this goes back to, I'm going to finish writing with the way we think it would be. 1 or 2 tail. And alpha. There's one other thing that goes in this section. Our claim, our null hypothesis, is that the two proportions are what? Are the same. So we have to actually use that in our tests. Did we make that claim with interval? No. So we put the two together to find a P hat C. This is your pooled P-O-O-L-E-D or combined P hat. And we do this by finding x1 plus x2, which is how I got these numbers up here. Over N1 plus N2. Now, back to this, technically you only use this if your null hypothesis is claiming that they are equal. If we actually ever plugged in a number there, we would not use P hat C. But as far as our class goes, they could technically ask something about that on the AP exam, but as far as our class goes, we mainly just do 0. So our test statistic equation I'm going to write the old one over here. P hat minus P naught over square root of P hat. This will be P naught. P something. I'll write it 1 minus P something over N. I'm going to use this form, but I'm going to change it. So this is our sample value, but now I have 2 of them. So instead of just writing P hat 1 or P hat 2, I do what with them? Subtract. So it's going to be P hat 1 minus P hat 2. I always, by habit, put a parentheses around that because I say that this whole section is now this. Now, our P naught value, we don't have a P naught value, but that's like our claim. So our claim was that when I subtract them, it's going to be what? Yes, equals. So specifically, when I subtract it, it'll be 0. I'm going to technically write number here, but that's almost always 0. And then the bottom is my standard deviation. So when we dealt with interval, we took p hat 1 parentheses 1 minus p hat 1 over n1 plus p hat 1 plus 1 minus p hat, the p hat 2, 1 minus p hat 2 over n2. But here, we're using the fact that we are claiming that they are the same, so we're using p hat c in both of these. So we're going to have p hat c, 1 minus p hat c, in relation to our first sample size. And then we're also going to have p hat c, 1 minus p hat c, in relation to our second sample size. So this only happens with a test because we are claiming that the two different proportions are what? The same. So we do not do pooled combined with intervals because we're not claiming that they are the same. And then draw shade. There's a curve somewhere that you're going to draw in shade. Don't draw this. Don't write this. And then we always end our test by comparing what? P-value versus alpha. And then however you choose to do it of this or less than or not less than, whichever way you want to do that. I'm gonna time-wise not conclude right now because you should be able to write it. So we reject or fail to reject the null hypothesis, which in this case would be P1 minus P2. So putting a minus there, everything else is the exact same as anything we've ever written. So you guys can conclude on your own.